So we're looking at section 9.2, talking about relating two proportions to what a population would be. So if we consider question number 10 in here, question number 10 talks about cardiac arrest at day and night. So it says a study investigates survival rates for in-hospital patients who suffered from cardiac arrest. Among 58,593 patients who had cardiac arrest during the day, 11,604 survived and were discharged. Among 28,155 patients who suffered cardiac arrest at night, 4,134 survived and were discharged. In this, and this is once again according to Survival in Hospital Cardiac Arrest During Nights and Weekends, Journal of American Medicine, so on and so forth, we want to use a 0.01 confidence level to test the claim that the survival rates are the same for day and night. Okay, and we're going to test this using a hypothesis test. Now, one of the things we're thinking about is we're also going to test this using our confidence interval, and then we're going to see, based on these results, does it appear that for in-hospital patients who suffer cardiac arrest, survival rate is the same for day and night. So really we're comparing, is the daytime crew better than the nighttime crew where they can save people, or is the nighttime crew better than the daytime crew, or they have some equality in here. So we have a whole bunch of information. We're given a couple different statistics, okay? We're given our daytime and then our nighttime, okay? So the number of daytime cardiac arrests was 58,593, and out of that 58,000, 11,604 survived. Under the nighttime, so the number of nighttime ones that came in was 28,155, and out of that, we had 4,139 survive. So if we look at these numbers, basically what we're stating is we have a proportion here, this out of this out of this, then for a second proportion then. And then we're going to be comparing these. So if we're using our hypothesis testing, our null hypothesis is going to relate to, does proportion 1 equal proportion 2? If we think back, our null hypothesis was always, in the past, our proportion equals some number that we're referencing towards. Well, now we're comparing this daytime crew and nighttime crew to each other, so we're going to test the equality of it, and then our alternative hypothesis is going to suggest not equal to. Okay, once again, we're not necessarily comparing the simple fact that we have an overall who's better. It's, are they the same or are they not the same? Okay, because it says based on the result, does it appear that the in-hospital patient who suffered cardiac arrest survive rate is the same for day and night? So it's either the same or it's not the same. So as we consider what's happening in here, as we're looking at our features, we need to bring out our calculators. Okay, so if we bring out our calculators, once again, this is going to be using our value. So I'm just going to bring in a new nice clean screen here on a calculator. Once again, it's had some other saved data in here, but that's not the biggest thing that we're referencing towards. So if we're considering what's happening here, we're going to go Menu, Statistics, Stat Tests, and then now we're considering a proportion. Okay, so a proportion, but now we got two proportions. So rather than having a one proportion in comparison to some number, we're now comparing that we have an actual two proportions. So we type this in, and notice it gives us our x sub 1, n sub 1, x sub 2, n sub 2. So we're just going to go and we're going to type in our values. So I'm going to type in 11,604. I'm going to type in my 58,593. Then for my second one, I have 4,139, and then 28,155. Now, Down here in our hypothesis, in our alternative one, once again, we could have that not equal to. If I come here in that hypothesis test down here, we could have, is one proportion greater than another? Are they not equal to each other, or is the other one greater than? So we could talk about, is our first proportion have a higher survival rate than the second one? In this case, we're worried about, is it different? So that's where we're just going to go with this not equal to on here, and we're going to leave it in that fashion there. So say enter, and so I see I have my x sub 1, n sub 1, x sub 2, n sub 2, and then my alternative hypothesis that I just type in, and now I hit enter, and we see that we have all this information. It gives us the proportions for 1, the proportion for 2, it tells us p hat overall, and gives us our test score. So we see that our test statistic is z equals 18.26. Our p-value right here is, I'm not going to write this one out. I'm going to go 1.81 times 10 to the negative 74th. I might be writing a lot of zeros in here, 73 zeros. So that would be quite a bit going on. So if we consider what's happening here and all this with the p-value so extremely low, remember we wanted to have a significance level of 0.01. We are definitely less than 0.01. Okay, so we are going to reject the null hypothesis. Okay, once again, when this p is low, the null has to go. So we're going to reject that null hypothesis. So we're rejecting the fact of equality. So now we're siding with the fact of inequality. Okay. Let's see here. Let's change colors. There is sufficient evidence to reject the claim that the survival rates are the same, okay, are the same for day and night. Okay, so we're rejecting that claim because, once again, there's more there. The claim was that we have some equality in here, and no, we're not showing that at all. We're rejecting the equality. We're saying it's not equal to. But once again, we aren't testing it with what side is. Now, we want to do the same thing. We want to work the same thing, but now let's use a confidence interval. Okay, so we're looking at part B. Okay, part B asks us to use a confidence interval in this. Now, do realize we're working through the same problem. We should be coming out with the same results. It's just now we're going to be using a little bit difference on here. So, once again, I go to my calculator feature. Under the calculator feature, you can go Menu, Statistics, and now we're going to look at confidence intervals. Okay, if it asks for a confidence interval, we go to a confidence interval. That's a nice part about this calculator and not that 83, 84, is it's that drop menu a little more user-friendly on here. Okay, so if we look at right here, we see once again 2 prop z interval, so a 2 proportion. Okay, so we go down here to that 2 proportion z interval, and it asks us the exact same thing as it did before. We're going to type in our 11,604. We're going to type in our 58,593. And then our second one, our x was 4139, and then we had 28,155. Confidence level. Okay, now we got to decide our confidence level. Okay, so we should come back here and go confidence level. once again, we have to relate to what is happening on this. Okay, what is overall happening on this? Okay, we want a significance level of 0.01. So if you remember back, I told you that you should mark this page. Okay, so page 399. 399 talks about significance levels to confidence levels. Okay, we are in a two-tail test. So we have a two-tail test. So we're two-tail, and we have a significance level of 0.01. That means we want to have 99% confidence. Okay, once again, that table is on page 399, where they talk about a two-tail test. 0.01 our significance level leads us to a 99% confidence. If it was one tail, it'd be a 98% confidence level. So considering this with everything that's happening here, we have that 99% confidence. I'm going to come back here, and then I'm going to type in 0.99. Okay, because once again, okay, so I have my x1, n1, x2, n2, and then my confidence level, I want a 99%, so 0.99 for a value confidence level. And then I hit OK. And what we see here now is we get a whole bunch of information in here. But this is what is really telling us, okay? So our confidence level is going to be 0.0441 less than proportion of 1 minus proportion of 2. It always calculates towards this, that we're taking our first one minus our second one in here, and then 0.0579. Okay. Okay, so as we continue looking at this confidence interval right here, we see that we do not include 0 in this. Okay, so there is no 0. I'm just going to write this off to the side. No 0. Okay, so no 0 means that this subtraction in here could not have any equality. So thus, we're siding with the fact that there is some sort of inequality in here. Now, if we think back, all of these numbers are going to be positive. Okay, so all of these numbers are positive numbers. So we have positive values in here. Okay, so because we're getting positive values, we see that proportion 1 would have to be greater than proportion 2. Okay, even though we tested it with a not equal, we tested here 99 with a 2 tail that it's not equal, our overall value, because it's not, there's no 0 included, we're rejecting the fact that there's equality, we're showing that a proportion 1 is actually greater than proportion 2. So we're seeing that there is a higher, okay, so that there's sufficient evidence to reject the claim that the survival rates are the same. Okay, so this right here, this no 0, is once again that same statement we had up here, that we can reject the claim that the survival rates are the same because there's no 0. But in part C, we can even extend this and say in that we're showing signs that it appears, so in part C, it appears that daytime has a higher survival rate than night time. Okay, so we're seeing the fact once again in this confidence interval, because that we're positive overall, that our first proportion has to be greater than that second proportion to get positive numbers in here. So that's what we're seeing towards here. So then we can make a generalized kind of appearance. Now, we don't want to come out and state that daytime's better than nighttime, because that creates a mass hysteria, especially in our health industry and people not wanting to come in. And that's basically what could happen if we think about nighttime. When are people finding this? If it's a heart issue, cardiac arrest, are they caught right away as they would be during daytime so they have a better chance of surviving? Maybe that nighttime crew is running on a skeleton staff so they don't have the facilities to constantly get around, and they might have to maybe delay 30 seconds to do something, and 30 seconds in a life and death situation could have some major issues. So we as mathematicians are never going to state that this is better. We're just showing that it appears that we're seeing a higher rate, and that's where a business would have to come. Now, this was an example of a two-tail. Let's continue on and let's look at a one-tail one. Okay, I gave you the hint on what's going to be happening on a one-tail one. We're going to look at problem number 12. Okay, on problem number 12, here we talk about bed nets to reduce malaria. So, in a randomized controlled trial in Kenya, insecticide treated bed nets. So insecticided treated bed nets. You know, this is why I'm a math teacher. Can't read, would not be good in the English class, even though statistics is a lot of English in here. Bed nets were tested as a way to reduce malaria. So, among 343 infants using bed nets, 15 developed malaria. So, N1, I'm going to have be 343, so then X1 would be 15, and these are my bed nets. Okay, so this is my population with bed nets, and then I'm going to go with and then without bed nets would be my second population, or my second data or statistics that we're relating to here. 294 and then 27 developed malaria. Okay, we want to use, so we're going to use a significance level of 0.01 to test the claim that malaria is lower for infants using bed nets. So the claim malaria is lower with using the bed nets. Okay, so it's kind of abbreviating what's going on here for everything. So we're going to come to our hypothesis test. So part A, we want to hypothesis test this. So our null hypothesis. Our null hypothesis is talking about a proportion of 1 equaling the proportion of 2. Okay. In our alternative hypothesis, because we're testing that one is better than another, that this malaria rate is lower, that less people, less infants that actually have these bed nets get less malaria than ones that don't get the bed nets. So we're testing that this other one is here. So our claim is siding with our alternative hypothesis. Remember, if our claim is the null, then this is not equal, thus making a two-tail. Gave you the hint, we're doing a one-tail test. Once again, we're going to come in here. We're going to be running our statistics test, so our stat test, a 2-prop z test. Okay, so in this 2-prop z test, we're going to be typing in our information for our first population and then in for our second population. But now we are not going to be equal. We are testing the fact that our first population, or proportion right here, and I keep saying population, but I should be saying statistic because it's a group. I got a glare really bad right now. Alright, I'll come over here. Okay, so X1 was 15, N2 and N1 was 343, and then 27 here. Once again, this was with bed nets, this was without bed nets, so I'm testing now my alternative that my statistic right here of proportion is less than my second one. So we come in here and we hit enter and we get our values. So we see that z equals, so once again, z equals, so our test statistic, z equals negative 2.44. Our p-value equals 0.007366 is what the calculator gives us. So once again, we write the test statistic just in case we had the values. Do realize we're testing a one tail, and where this one's less than this, so we're testing the left side of this. So we have this value right here, and we see that, oh hey, 0.01 significance, we're definitely less than this significance. Because we're less than this, reject the null hypothesis. So we're going to reject the null hypothesis, in which then now we're going to be stating in favor. So there is sufficient evidence. So there is, and actually I would just go like this, there is evidence. I wouldn't necessarily call this sufficient evidence, because 0.01 would be right here. If I round this, I'm at 0.01. So I would just say there is evidence to support the claim that bed nets with insecticide lower the rate of malaria. So lower the rate of malaria. Okay, and just because we're looking at this. Now, let's do our confidence interval on this, okay? So our confidence interval, once again, we have a significance level, 0.01. We have a one-tail test now, okay? So now we're going to go back to our page 399. So let me go back to page 399 in my book. Here we're looking for a 98% confidence. So our confidence level is 98% confident. Okay. Looking at this now, we're going to basically do the same thing. We're going to come in menu, statistics. But now instead of going in stat test, we're going into confidence intervals. And we're looking at a two data, once again, proportion z interval in here. And then we're going to type in our information once again. And then now we're at a 98% confidence interval, so I'm going to type in the 0.98. So we see that we have our 15, 343, 27, 294, and then 0.98. We hit enter, and then we see that our values right here we get as a lower one of negative 0.0950, less than P1 minus P2, less than negative 0.0013. Okay, so as we're comparing this, as we're looking at this, do realize that 0 is not included in this. Okay, so 0 is not included, so that means it's not equal. And actually we're seeing that P1 minus P2 showing all negative values, thus making P1 smaller than what P2 would be. So that means we're showing signs, once again, that P1 is less than P2, okay, which is showing signs that we are in here. So basically we are 98%, but because the confidence interval does not include the 0, it only includes negative values, it appears that this malaria rate for this is less than what the second one is. So it is appearing that bed nets are effective. Okay, so basically we conclude on here, it appears that bed nets are effective. Now once again, if we remember back here that we are 98% confident that the difference of our proportions is going to be in this interval. Okay, so we're not 100% certain that this is going to happen. We're 98% certain that this is going to happen, and based off our conclusions, this is what we start concluding on here. And once again, this is what happens on the one tail versus our two tail.